That action creates a block that represents that specific transaction or data. The block is sent to every computer node in the network. Authorized nodes verify the transaction and add the block to the existing blockchain. Nodes in public blockchain networks are referred to as miners. They're typically paid for this task, often at a process called proof of work, or POW, usually in the form of cryptocurrency. The update is distributed across the network, which finalizes the transaction. These steps take place in close to real time and involve a range of elements. Figure 1 shows the block creation and verification steps in more detail. A blockchain ledger consists of two types of records: individual transactions and blocks. The first block consists of a header and data that pertain to transactions taking place within a set time period. The block's timestamp is used to help create an alphanumeric string called a hash. After the first block has been created, each subsequent block in the ledger uses the previous block's hash to calculate its own hash. Before a new block can be added to the chain, its authenticity must be verified by a computational process called validation or consensus. At this point in the blockchain process, a majority of nodes in the network must agree the new block's hash has been calculated correctly. Consensus ensures that all copies of the blockchain distributed ledger share the same state. Once a block has been added, it can be referenced in subsequent blocks, but it cannot be changed. If someone attempts to swap out a block, the hashes for previous and subsequent blocks will also change and disrupt the ledger's shared state. When consensus is no longer possible, other computers in the network are aware that a problem has occurred and no new blocks will be added to the chain until the problem is solved. Typically, the block causing the error will be discarded and the consensus process will be repeated. Overstock.com used blockchain to sell and distribute more than 126,000 company shares. That marked the first time a publicly traded company used blockchain to support stock transactions. R3, a global consortium of financial institutions, also uses the blockchain-like Corda platform to record, manage, and synchronize financial information using blockchain APIs for specific platforms. Banks and financial institutions across the globe continue to be leaders in blockchain adoption. Other industries, including healthcare, government, and technology, are furthering their use of blockchain to enable the secure exchange of data such as personal health information, digital assets like downloaded entertainment, and real estate deeds. Manufacturing and similar businesses also see potential to use blockchain to manage smart contracts and track materials as they move through supply chains. Types of blockchain. Blockchain platforms can be either permissionless or permissioned, see Figure 3. Permissioned blockchains require approval to access, making them essentially private blockchains. Permissionless blockchain does not require permission to enter the blockchain network. In a public, permissionless blockchain like Bitcoin, every node in the network can conduct transactions and participate in the consensus process. In a private, permission chain like multi-chain, every node might be able to perform transactions, but participation in the consensus process is restricted to a limited number of approved nodes. Numerous blockchain platforms are available, but three of the most prominent are Ethereum blockchain, Hyperledger Fabric, and OpenChain. Ethereum blockchain is a widely used, open-source, and custom-built blockchain platform considered to be an industry-leading choice for enterprise applications. Hyperledger Fabric is another open-source blockchain platform. Used by industries such as finance and manufacturing, it is designed for permissioned networks. Hyperledger Fabric can also be used for decentralized hosting and storage of applications that employ smart contracts. OpenChain is an open-source blockchain platform for organizations that want to manage and preserve digital assets. An administrator of an open-chain blockchain will define the rules used in the ledger. Users can then exchange value on the ledger by adhering to the rules. Blockchain adoption considerations. Any enterprise considering whether to implement a blockchain application should first consider whether it really needs blockchain to achieve its objectives. Blockchain does indeed have several significant benefits, particularly in security, but it's not a replacement for all database needs. In fact, conventional, centralized databases are often the better option in many circumstances, especially when speed and performance are critical and transactions only happen inside the enterprise or between a limited number of entities where trust has been fully established. In choosing a blockchain platform, an organization should keep in mind which consensus algorithm to use. The consensus algorithm is a core piece of a blockchain network and one that can have a big impact on speed. It is the procedure through which the peers in a blockchain network will reach agreement about the present state of the distributed ledger. This helps establish trust between users of the blockchain. There are 4 standard methods blockchain and other distributed database platforms use to arrive at a consensus. Common consensus algorithms include the following. POW, which is used to select a miner for the next block generation. Generally, public platforms choose POW algorithms because they are easy for other network nodes to verify. Practical Byzantine fault tolerance, PBFT, an algorithm designed to work in asynchronous systems. Proof of stake, POS, algorithms that are commonly used as alternatives to POW. They work by having validators invest in the currency of the system by keeping some of their coins as stake. The validators then begin validating blocks. Delegated proof of stake, DPS, algorithms for a voting and election process designed to protect against malicious use or centralization in the blockchain. Blockchain, gaining the ability to overwhelm the other participants on the network. This type of attack is unlikely, though, because it would take a large amount of effort and a lot of computing power to execute. History of blockchain. A protocol similar to blockchain was first proposed in a 1982 dissertation by David Chaum, an American computer scientist and cryptographer. In 1991, Stuart Haber and W. Scott Stornetta worked on furthering the description of a chain of blocks secured through cryptography. From this point on, some individuals began working on developing digital currencies. In 2008, a developer or group of developers working under the pseudonym Satoshi Nakamoto developed a white paper that established the model for blockchain, including the hash method used to timestamp blocks. 1 year later, in 2009, Satoshi Nakamoto implemented a blockchain using the currency Bitcoin. To this day, no one knows for sure who Satoshi Nakamoto really is. Interest in enterprise application of blockchain has grown since then as the technology evolved and as blockchain-based software and peer-to-peer networks designed for enterprise use came to market. Enterprise leaders started to look more seriously at the technology early on, seeing more and more potential as early as 2014, when blockchain technology started to become more distinct from the idea of a specific currency. At that time, experts started to see blockchain's potential for financial transactions in general as well as its potential for other organizational transactions. Actual adoption was slow. In 2019, Gartner found that just 1% of CIOs were adopting blockchain. Just a little more than that 8% were in short-term planning for looking into or implementing blockchain, with financial services, life sciences, and healthcare among the industries with the highest rates of blockchain adoption. The 2020 Global Blockchain Survey from Deloitte showed further growth in enterprise interest in the technology. In 2018, 43% of responding C-suite executives said blockchain will be critical and a top 5 strategic priority. The number climbed to 53% in 2019 and to 55% in 2020.